Hey guys, I just wanted to make a quick video as a tutorial for this leak code problem. These are the types of problems you'll get in like software interviews or you'll see in like interview prep books. For example, like the famous one, which is something coding, something mock interview, something. But yeah, anyway, right now it's kind of an interesting time in tech because there's uncertainty about the industry because people are getting laid off. There's lots of people still trying to join because salaries. And there's also ChatGPT advancements that make it, easier for people to cheat. To the last point, it's no substitute. You should have your smarts about you, and you should have the reasoning and pattern matching to do well in these. So yeah. So given an integer n, classify it as either even is the terminology I use, meaning it can be split into two equal integers, or not even. I guess you can also call it odd, meaning it cannot be split into two equal integers. So I'm in Google Colab now. The input for n should be 1 to a million range. We have our code here, and then we just have our test cases, which should pass and should run this message and not these ones. So the first thing is when you're approaching a problem in an interview, you want to start with like the most basic solution you can think of. You can work your way up, and it's a good excuse if at first you're not able to get the question right. So we can think of the brute force approach. When you think about what we're trying to do, we're trying to map a specific number to its parity. We could do that mapping in the code. If we know the range, which is just 1 to a million. We could do something like if n is equal to 1, then we would return false. And 1 would be not an even number. And then we could just continue this through, make sure that you catch all the edge cases. Okay, so I finished writing the code. Let's run it now, see if the test case is passed. Okay, awesome. So you can see this method works. Some issues with it are the readability is not great because you have this like big column of if statements. Some people might say it takes a long time to write. It doesn't take too long to write, and even so, it builds character. But it is a good solution. However, in these types of interviews, it's good to start with a basic solution and then show that there are also different solutions because, even though this works, the recruiter might be a bit picky. So one thing you might notice about this problem is that it lends itself well to a recursive solution. If we have the information for some number n and we have the parity of n minus 1, we can actually derive n from that data. For example, if the parity of n minus 1 is even, then we know that n is not even. And then the other key point is that if we have n minus 1 and we want its parity and we have n minus 2's parity, by the same logic, we can get it based on the data. So we can start with the base case of 1, being if n equals 1, we would return false, as 1 is not even. And then otherwise, we can just return is even of n minus 1. Of course, we know that if the parity of n minus 1 is not even, then the parity of n would be even. So we have to put a switch here. So we can run it to see if it works. And there we go. So a common step after recursive implementations would be to use a DP or memoization approach. Recursion functions, if called too many times, can have Stack Overflow errors. And instead, we can just learn to use the same recursive logic, but apply it iteratively. So we would go through the numbers up until n. So for I in range 1 to n plus 1, we would be filling this list with the parities from the numbers 1 to n, and then at the end of the day, we would return answers of n, I minus 1. And in fact, I think we would want to populate this starting parity of true, so 0 maps to true. I didn't think about if 0 should map to true or false, but it doesn't matter. And 1 would map to the next one, and that's why we're doing I minus 1. We're going to append 1 to it, and then all the other ones are going to use the values from before, and we should have the not value here. And there we go. Cool, so one more thing you could do is slightly improve the space complexity of this solution. And companies will not necessarily expect you to do this, but it's just a trick you can see, which is that in this code, we are using a list to store the answers for the parities from 0 to n or 1 to n. And the reason we do that is because we need the value for n minus 1 to solve for the parity of n. But in reality, we do not need to store every single value. We just need to store the most recent one. We can basically take this code, and instead of storing a list, we just store the most recent answer. If I equals 1, then we're going to set the most recent answer to false. And otherwise, we can just set the parity of answer based on the previous parity, which is exactly the same logic as before, but now we're not using a full list. So yeah, that's the typical dynamic programming question process where you go through a couple of methods. Hope that was helpful.